Hi there everybody, welcome back, this time to our very last video lecture of data structures. You all have been working super hard this semester, especially after all of this coronavirus and online learning stuff has happened. So I want you to know that I'm very proud of you all. You have had an immense challenge, but you have risen to the challenge and done very well. So in this last lecture, I'm going to talk about two things. The first is we'll do some administrative stuff about talk about grades and what all that's going to look like. And then the second thing is the actual material for this last week of class, which is the graph data structure and graph traversals, and a key algorithm called Dijkstra's algorithm. Okay, but before that, let's talk administrative stuff. So again, you all have been working super hard and finals is coming up, and I'm guessing that that's a particularly stressful final season for many of you this semester. And so what we're going to do in this class is I'm just getting rid of the final. Yeah, so no final in this class. Your last homework assignment, the one we're going to talk about in this lecture, will take the place of your final. And so this really is going to be the last assignment of data structures. And so this last assignment we'll see in a little bit as we talk about it, but it's going to actually be a very comprehensive final. It's going to tie into a lot of the things that we've done in the beginning of the semester with stacks and queues. And so I feel very good about this being a sort of like final homework assignment for the class. Yeah, so grade-wise, all of your assignments that have been submitted so far have been graded, so you should know what your grades are. There's a couple of, so homeworks 9 and 12 and 13 are all due pretty much right now after I'm done creating this video. So as soon as you get those submitted, I'll grade those as well. And so the only only thing left of your grade will be this last assignment. So you should have a very good idea of what your grade is going into this assignment. And if you have any questions about your grade, feel free to send me a private email and I can answer those for you. Or if you have any questions on how you can improve your grades still at this point, definitely let me know and I'm happy to work with you. One last point about grades is that this last project, this last homework assignment, is going to be worth a little bit more points than your previous homework assignments. It'll be worth 30 points instead of 10 points. So that 30 points comes from the 10 points from the normal assignment points, and then the 20 points that would have been towards the final are getting incorporated into this assignment. So yeah, it'll be worth a little bit more, but the assignment actually is not, I don't think it's definitely not 3 times harder than any of your other assignments. And personally, I think the AVL tree assignment and the heap assignment were both more difficult than this assignment will be. Okay, and yeah, so due date for this assignment is going to be the last day of finals week, May 15th. If you really need an extension from that, I can give you a couple of days extensions, but grades are due really soon after that, so I can't give you too big of an extension. So really try to get it finished by May 15th. Okay, so that's all the administrative stuff out of the way, and we're ready to talk about the assignment itself and this new concept of a graph. As a quick teaser, before we get into the details of what is a graph, in this assignment, you're going to be creating some mini artificial intelligence algorithms for the board game Risk. So Risk is a classic board game where you have armies on the world and the goal is to take over the world. So we will be using our graphs and our graph algorithms and our data structures to literally take over the world in this assignment. Okay. So yeah, again, I'm on the course webpage right now in our homework 14 folder, and currently we're just looking at the README file, but then there's also this lecture.md file, so I'm going to go over and look at that. And this has the big high-level overview of things you need to know about graphs. So one of the key takeaways that I want you to sort of take away from this assignment is that graphs are a super unifying concept throughout all of computer science. And most problems can be solved by first somehow cleverly converting your problem into the language of graphs, and then use some sort of graph algorithm on that problem. And it'll turn out, as we will see, that most of your previous homework assignments actually follow this pattern of first think of the problem as a graph and then apply graphs to them. It also turns out that Git is just a giant graph algorithm tool. All of these commits and pushing and pulling, all of those are just manipulations of what's called the underlying repo graph. So there are many, many graph algorithms. If you're interested in this, then I highly recommend you take Professor Sarah Cannon's graph algorithms course next semester, because he'll be going into lots of details about this. So you can think of this as like a teaser for what that course is about. And we're going to talk about three algorithms in particular: the depth first search, the breadth first search, and Dijkstra's algorithm. Yeah, we talked about depth first search, DFS, and BFS a little bit in the context of trees, and it turns out these algorithms are also applicable to graphs. And then Dijkstra's algorithm is really like the sort of most important algorithm for graphs. And so Dijkstra is a famous computer scientist. His name is Dutch. So this J right here, you don't pronounce it like J. You don't pronounce it that way. In Dutch, the J is pronounced like an English Y. So it's just Dijkstra is how you pronounce his name. So then it's Dijkstra's algorithm. And this is an algorithm for finding the shortest path in a graph, which turns out to be a very, very widely applicable problem. And so we'll see that each one of these algorithms has a data structure associated with it. That depth first search is a stack, breadth first search is a queue, and then Dijkstra's algorithm is the priority queue, which is another name for the heap, which you implemented in the previous homework assignment. And then there's the runtimes of the algorithms over here. So these runtimes are a little bit more complicated than runtimes that we've seen before because there's two variables inside of this big O notation. This V is the number of vertices in the graph, and this E is the number of edges in the graph. It turns out that there are many, many representations of graphs, and so it's possible to rewrite these things in many, many different formulas. So these things are not formulas that anyone would expect you to have memorized. The runtimes of like binary search and all the sorting algorithms and the AVL tree, binary tree heap algorithms, those are things that you sort of definitely need to have memorized. And there's sort of like only one right answer for those. For these, the answer is a little bit more complicated and you have to be a little bit more formal, so you don't have to memorize these runtimes. The main thing to take away, though, is that they're relatively efficient runtimes, so they're all linear in either the number of vertices or edges. But Dijkstra's algorithm is a little bit more complicated than the other two, that it has this extra logarithmic factor over here. Okay. So videos for this lecture series, there's these two first videos, which you definitely have to watch. They go through at like an intuitive level, what does it mean to do each of these algorithms on a graph. And so you'll want to have the intuitive understanding down before we go into the pseudocode. So definitely watch these two videos after this one. These two videos right here provide some Python code for how to do breadth first search and Dijkstra's algorithm. and these are the algorithms that you will be implementing in the homework assignment. So feel free to adapt this Python code into your homework assignment. But they do use a slightly different sort of like coding structure than we'll be using, so you're not going to be able to sort of like one-for-one copy any of this code. But if it's helpful for you to see somebody else's code on how to do this, feel free to do that, but not required. The last video that you should watch is a little bit more of a kind of high-level video about something called P versus NP complete problems. And these are roughly like, well, I'll just let you watch the video. It explains, so P versus NP is how we talk about what types of problems are efficiently solvable versus what types of problems cannot in principle be solved no matter how good of an algorithm somebody will ever generate in the future. And so two other very famous graph problems that we're not going to have a chance to cover are the minimum spanning tree problem and the traveling salesman problem. So those are things that I would recommend looking into at some point on your own if you plan on having a career doing computer science programming related things. And again, I just want to really plug Professor Cannon's course for next semester, because she'll be going over all of this stuff in great detail. Okay, so at this point, I'm going to stop. You should watch these two videos and this video and these two if you want, but you don't have to watch these two. And then join me again for our next video where we'll go over the actual homework assignment. So see you then.